Hey everyone, welcome to the last video for section 3.4. So in this video we're just doing a couple examples of solving equations with repeated roots for second order linear constant coefficient homogeneous equations. That's a lot of words. But anyway, let's go ahead and jump right on into it. So example 1 is find the general solution to y double prime plus 4y prime plus 4y equals 0. So how do we do this? We find the characteristic equation, which in this case is r squared plus 4r plus 4 equals 0. 2, we find the roots. Now in this case, these are all going to factor really nicely because they're all perfect squares. So r squared plus 4r plus 4 is just r plus 2 quantity squared. So this has a double root at r equals minus 2. So we need to write the general solution. And this is just what? Y of t equals c1 e to the minus 2t, because our root is minus 2. And since it's a double root, what do I get? For the second one, I get c2t e to the minus 2t. And that's my general solution. This problem should be going a lot quicker than the ones from chapter 2. And that's the point. These are all constant coefficients, so they're easy. All right, and that's it. That is my general solution for this ODE. Now we'll do a second one where we need to find some constants. So example 2 says solve y double prime minus 6y prime plus 9y equals 0, y of 0 equals 3, y prime of 0 equals 1. All right, step 1, characteristic equation, r squared minus 6r plus 9 equals 0. Step 2, factor it. This is r minus 3 quantity squared. So double root at 3. And then part 3, general solution, y of t equals c1 e to the 3t plus c2t e to the 3t. Right, because that's how we get our general solution for repeated roots for a second order equation. And now I want to find constants. So then if that's y, what is y prime of t? Well, then y prime of t is going to be 3c1 e to the 3t plus c2 e to the 3t plus 3c2t e to the 3t, using the product rule on the second term there. So now let's try to find our initial conditions. So y of 0 we want to be 3, and y prime of 0 we want to be 1. So what is y of 0? Well, if I plug in 0 there, I get c1 plus 0 because t is 0. And for the second case I plug in, I get 3c1 plus c2 plus 0. So this here tells me c1 equals 3, and this here tells me 1 equals 3 times 3 plus c2, so c2 equals minus 8. So if I plug in that and that into my condition, into my problem, I get that my solution is y of t equals 3e to the 3t minus 8t e to the 3t. And there's my solution there as well. Not too bad, right? These problems are not too hard, and you should be able to figure them out. We should be able to do quite a few of these in class tomorrow. All right, that's it. There's two examples, one with conditions and without conditions, for solving these problems that have repeated roots. All right, thanks a lot for watching, and I'll see you in the next section.